You started a quiz. Oh,
Who's that?
Sean and Crystal.
All right, of course. There we go.
Thank you.
All right, I think everybody submitted it. Let me look real quick. I assume you're Millie, right? You're Millie? Billy, Sergio, Cole.
It was humbled.
Oh, no. It's not that serious.
Sure.
All right. I'm only missing Sean, but. How did I put it? All right, here we go. We're gonna go over this. Share the screen. All right, here we go. So first question, March, you can read the first, please.
When can you log nighttime landing currency? 1 hour after sunset to 1 hour before sunrise.
That is absolutely correct.
So there's a difference between that and. Sense of nighttime. Right.
Yeah. So there's three operations that happen at nighttime, really. There's the official sunset to sunrise, right? That's considered nighttime in the sense that you have to turn on your nav lights.
And official, and that's the civil twilight, 6 degrees or.
Yeah, the civil twilight is usually 60, which is about 30 minutes past. So that's the second operation, right? So the second operation would be 30 minutes past sunset, 30 minutes prior to sunrise. You're allowed to log the nighttime. But technically, if you actually left 30 minutes past sunset, that would mean that you could not log the takeoff as a night takeoff. It would still be a daily takeoff. So that's one definition. Sunset to sunrise is nav lights go on. 30 minutes past is, or 30 minutes before, that is going to be nighttime. You can log nighttime. And 1 hour past sunset, 1 hour before sunrise, you can officially log landings as night. Yep. Good. Craig, next one, please. I mean, we just answered it, but please go ahead, because I see a whole lot of answers here.
The end of evening civil twilight to the beginning.
Perfect. I just mentioned this, but I see these answers and they're kind of like flustering. 30 minutes past sunset, 30 minutes prior to sunrise. So I think right now it's like 7:22 p.m. So at 7:52, you can officially log nighttime. Sunrise is, I think, at 6 or something, whatever. So until 5:30, you can log nighttime. Sergio?
But do you need your nav lights on? Sunset to sunrise.
This is should I repeat this one more time or I don't know? This is confusing, these answers. All right. But it's also not only you guys, it could be some old tests. Yes, sunset to sunrise, you turn on the nav lights. That is correct. Daryl, please.
Which mean is the red navigation light on? But
Left, that is correct. What's on your right? Yep. March?
Can you fly at night with one of the navigation lights not working? No.
That is a no. That is absolutely correct. You had that what, son?
I got it.
Right on.
They were the ones that messed up the sunset too.
Yeah, I mean, I see the answers here.
Yeah, so.
Um, You don't have to throw them on the bus. What color flashlight should pilots use during night operations? Who chose white? Anybody know who chose white? Anybody who chose white? White, anyone? It's red for the operation in the plane. How do you pre-flight a plane?
Like that here.
Why is it white?
So you can see fluid colors. Using red light and red fluids on the ground, you probably are gonna mess it.
Yeah, if you use red and the hydraulic fluid is red, you cannot really see it. So that's why you still use white during the pre-flight.
So when the little light behind.
Yeah. Yeah.
That's white, right?
No, that's red.
That is red? Oh,
Yeah, the one for the cabin light.
yeah, there's one back here that.
That one is red. Yeah.
Oh,
So that's what they're talking about.
all right.
During night operations, on except of the pre-flight, you should be using red colors. How long does it take for your eyes to fully adjust to darkness? It's going to be 30 minutes. What happens after 10 minutes? Anybody remember the answer?
10,000 times. Just like sensitive.
That's 100 times. After 10 minutes, your eyes get 100 times more sensitive. After 30 minutes, your eyes get 100,000 times more sensitive to lighting. All right. What can happen if you focus on a single object outside at night? It will appear to move. And what's that phenomenon called? Autokinesis. That is correct. Autokinesis. Part of what umbrella term? Spatial disorientation. If you see a white and green navigation light on a plane, which direction is the plane moving in relation to you? Left to right. That's correct. Flying towards you? No. What would you see if it's flying towards you? Green. What would you see if it's flying right to left?
Red.
I don't know. Left to right would be, I mean, the left to right. See, it's white and green.
Right to left, you see the left side airplane. So you see the.
Yeah.
You see red. Red and the scroll.
It's moving left to right. Don't you see the red light?
Left to right?
And you see the.
Oh, sorry, left to right. Yeah. Wait.
Left to right, because the green light's on the right side.
Oh, that's correct.
This way.
Right on. Yeah, just right forward. Sweet. Yeah, and right to left, you would see the red light.
Right.
Good. When flying VFR at night in a sling, what equipment is required? Anybody can answer? And with a definition, please, of why this is the case.
I think I got this one wrong, but it's the kinds of equipment list and. Bar requires.
So why does 91-205 come into effect here for us as a light sport aircraft? We have a kinds of equipment list.
Or equipment.
Yeah, we have a kinds of equipment list, that's correct. But technically, we don't follow 91-205 all the way until it turns night. And when it turns night, we actually do follow 91-205.
Why is that? For the
Because
daytime?
for the daytime, we don't need it because we're considered a light sport aircraft. A light sport aircraft falls under a different category of aircraft. And this one is 91-103. And the very first line in 91-103, I'm sorry, 91-205. So the very first line is already telling us,
Civil air.
yeah, standard, yeah.
That makes sense.
So we're not considered standard as a light sport
Okay.
aircraft. And that's why we don't have to follow it. But at nighttime, we do have to follow it because now you need those. All right. Does that make sense? Everybody can follow? When flying VFAR during the day in a sling, what equipment is required? There's your KOEL list. So if my airspeed indicator is not working, can you go fly?
No.
No, that's correct. If my if I'm missing the fire extinguisher, can I go fly? Why not?
Not part of your safety.
You cannot go fly because that's part of the KOEL.
KTOA.
Yeah, that's why you check for the fire extinguisher during the pre-flight. When flying VFR during the day in a sling, what equipment? Okay, we just did that. How can you visually identify airports at night without the runway lights on? That is going to be the beacon light. GPS. I don't know. I guess that's an answer, but it's not the best answer. As you start your final approach, you notice the airport rotating beacon light is flashing white, white, green. Can you land at this airport? No, it's considered a military airport. When can you land at the airport? During an emergency, yeah. Absolutely. You are 29 years old and get a first class medical. How long will you have a valid medical certificate? Yeah. How long is it good for as a first?
Well,
How long is it good for as a second if you get the first?
no.
How much?
Goes right to 3. Goes right to 3.
It goes straight to 3, yeah.
Yeah.
So 12 calendar months plus 0 plus 48 equals 60 calendar months. All right, Craig, can you read this, please?
You are 36 years old and get a first class medical. How long can you exercise the first class medical? 12 months.
Absolutely. Straightforward, right? At this point, I think we have done this so many times now that hopefully you will never forget. There's your little guide. Under 41st goes 12, then 0, then 48. If you get only the second, you get 12, then you get 48. If you get the third only, you get it for 60 calendar months. And that should always total this number down here. If you're over 40, you get the first, it goes into the second, then the second, it goes into the third. And the total number down here should always be 24 calendar months. If you only get the second, now it becomes 12 and 12. If you only get the third, it will be valid for 24 calendar months. Which of the following is a symptom of carbon monoxide poisoning? Daryl.
That would be busy.
What symptom would you have with euphoria? Oh, what? Which one?
This hypoxia.
Yeah, hypoxia.
It's just
Hypoxia. You definitely won't have situation awareness. Inability to feel pain. What could it be? Not necessarily. It's not really pain, that's why. I don't know. It could be hypoxia. Like, it's not really painful to die that way, but what's that? Yeah, yeah, if you just keep hypoxia, it's the easiest answer, right? Don't get yourself in a situation where you have to explain all four now, but it's not really painful to die that way, but you don't feel that you're actually about to knock out. What can a pilot do to mitigate fatigue? As simple as sleep, yeah. Have the other pilot fly, increase use of automation, no, it probably puts you more to sleep. Use non-restricted caffeine sources, supplements, that's a short term, right? What kind of fatigue do we have? there's two categories. Chronic is one,
And acute.
and acute, very nice. After drinking, you must have waited 8 hours and have a max blood alcohol concentration level of 0.04. Anything above that, you are not allowed. What are the other three? Well, okay, what's the total three scenarios? So we have 8 hours, 0.04. What's the third one? In regards of the FAR regulation.
No hangover?
Yeah, if you have drunk, let's say you drank something, drink, what do you say?
Drag.
You drank something. You drank something about 8 hours ago, now your concentration is even 0, but you still feel hungover, and you can't fly either. It could be 24 hours. If you still feel hungover, you cannot fly. Okay? When would a pilot suffer from histotoxic hypoxia? Hypoxia, they mean, yes. After drinking or using drugs. Anybody want to explain why?
Because the alcohol or drugs limit blood's ability to hold oxygen.
Yeah, exactly. The attachment of your blood, like blood has attachments to it, if you really think of it like that. And oxygen attaches to your hemoglobin, which is your blood cell. And drugs and alcohol have an easier connection to that blood than oxygen. They connect to it faster than oxygen. So now if you think of it like a building block, there's 4 sides to it, and each one can take one, right, attachment, like a puzzle. If you have just drank alcohol, you took some drugs, I don't know what you do, but 2 of those building blocks might already be blocked off with those toxins. 1 ounce of alcohol equals to how much? 2,000 feet, correct. To recover from hyperventilation, the pilot should focus slowly on controlling breaths. When will hyperventilation occur usually?
Yeah.
Panic, anxiety attack. Being in a situation they haven't seen before. Can happen in life. It doesn't happen only in aviation. But yes, these are usually the places where you find the person ending up with hyperventilation. What else can you do to
Same.
You can sing, yeah. Absolutely. Paper bag. What happens with a paper bag if you breathe into it?
Breathing in your CO2, so your CO2 content rises.
Absolutely.
Both gets brought to know.
Absolutely. Sweet. How does a pilot recover from a spatial disorientation? Flying based off outside references. You probably don't want to do that. Flying based off the plane's instruments. That's absolutely correct. You just want to focus on your, especially your artificial horizon, the attitude indicator. Turning on autopilot, that could help, but this is like proper FAA question, written questions, right? There can be 3 right answers, but only one of them is going to be the absolute correct ones, or the most correct one. What illusion can haze cause? Objects will appear further than they actually are. What other phenomenons can cause the appearance of something to be further than it actually is?
Black hole. No. Yeah.
That is one. Runway lights, fog, lakes, upslope, downslope, right? Something like that, right? can cause any of these. Per ACS, how fast, slow can your airspeed be during pre-flight, during slow flight, sorry. This is not correct. There's no zero, there's no minus, okay? That's the first giveaway. So if you see a -10, that's absolutely not right. If you see a -5, that's not right. Here we're getting closer to it, so it's kind of like, just use that method of elimination, right? It's definitely not zero, minus. You have to be +10, -0 on a private pilot level. So you choose a number that's going to allow you to at least drop 2. For example, you tell the DP that you want to fly 58 on the slow flight. You aim for 60. Okay, this is going to give you 8 above, 2 below, and you can still drop below, right? So don't say 58 and now you're screwed because you can't go below 58. Tell them 58, fly 60. It's going to give you 8 above, 2 below. How can a pilot avoid chronic fatigue? Yeah, I mean, good luck with that. By avoiding stressful situations, by sleeping, by seeing a doctor, by understanding fatigue. Yeah, this is a stupid question.
Yes.
But you I don't know. I don't want to say don't see a doctor, but yes, maybe do. That's your medical right there. Like you will be flagged, like I mean that's the elephant in the room that the FAA knows about. So you go see a doctor, depending what you're struggling with in life. Chronic fatigue by avoiding stressful situations, yeah. Stupid question, yeah. I mean, yeah, you want to avoid stressful situations, but sometimes you're just living life. Yeah. Sorry, it's stressful. Your passenger beings begins to feel motion sick. What can you do to help them? Yeah, increase airflow into the cabin. That's absolutely correct. Increase airspeed and goes back to the airport. Yeah, you probably don't want to get even faster. Descend to a lower altitude for smoother air could be a potential answer if it's turbulent at a higher altitude. Have them close their eyes. That's probably also not. You probably want them to look outside to the horizon. If you were doing something stupid like steep turns and stalls as a private pilot to show off, that's already a bad idea in the first place. But you probably want to stop that. Add some air to the plane, right? And that's pretty much it. Yeah, looks pretty good. Let's see what I know. We have a couple people on the hello, no sound, can't hear anything, no QR code. What? All right. Sean, can you hear me? Let's see if you can hear me.
Loud and clear.
All right, right on. Sweet. That was the quiz for this week. We talked about night operation and human factors the entire week, so that's already kind of covered. We did the quiz. We can do like a little review session. Hopefully you have done your homework so far. So I ask you a question, you answer to the question. How about that? Who wants to volunteer first? First question. Sure, yeah. You walk out to the plane, you do your run up at 4,000 RPM. You go to idle, the trim breaker pops. You put it back in. You go back to 4,000, it pops again. What do you do? Or first question, can you fly without a trim?
Technically, can without trim. Yeah,
Okay.
can. It'd be hard to tell.
Technically, you can, yeah. It's not part of anything, not the KOEL or 91205.
It just depends where your trim is set, right? If it's trimmed down or up, you're gonna be fighting it entire body.
Yeah, that's already a very good answer. All right, so now you put it back in, it pops again. What do you do?
I would just, if I wanted to play risky and it was at neutral, like Mayfly, but if not, I would just bring it back to maintenance.
Okay. Yeah, second part of that answer was not that bad. I mean, first part was good, second part was a little questionable. What would you do? Be close to the
I
fire?
personally wouldn't go fly.
Why?
If I did the whole time, because that's just. That could fall under a stressful situation you're willingly putting yourself into, sitting there either. Even if it is neutral, the plane still doesn't fly straight and level at neutral, so you're gonna be fighting it. You might miss like, get on with SoCal and they're like, stay at 3,500 and you like look away for 5 seconds. It's not that hard to gain a quick 150 feet without noticing.
Okay.
You're out of. No, I'm not flying person, I'll just take it back.
All right,
It's not
got
that
two
deep.
no's.
Because you're landing or something, you're fighting the trim all the way down.
Correct?
So,
We go fly? No. Yeah, the correct answer is probably not to go fly, especially if I'm pretending to be a DPE right now and you're about to get your private pilot's license, right? I don't know. You add stress to it, but the main reason why you don't want to go fly is the breaker popping out every time is telling you that something is wrong with the electrical system. Right? The electrical system, something might be off and something is not. It's like a shortage, right? The reason why it's breaking is because there's a shortage. So your direct current is somewhat disturbed by something. It can be the rectifier regulator, it can be just one simple thing that is really not allowing that current to arrive. So what if you go up and decide to go up? What could potentially happen, except of the fact that you're fighting the plane now to stay straight up?
Something.
Electrical fire, right? So how do you know it's an electrical fire and it's not anything mechanical?
it's still be wrong. Well,
That's a good answer, yeah. 9 runs. Hopefully,
yeah,
it could also not run.
you could burn up the electrical system, makes the plane run.
How would I know it's an electrical fire?
Some of your gauges would indicate that your engine's still kind of running smoothly, so like your oil pressure's still the same.
Okay.
Temps are the same, but you're still either getting smoke or something's.
All right, we're getting closer now. What type of smoke would you expect in an electrical fire?
Black.
Whitish, maybe? Black is like,
I don't think because it's burning all the wires, but you have rubber around or something with plastic and that has to be black. So
yeah, usually it leads to actually white smoke. Like more of a white smoke. The black is like fuel, oil. These things lead to a black smoke. So that's how you can differentiate between.
And I'm guessing it'll smell different, right? And
Yeah, very true.
or-
Yeah. If you have somewhat of an experience of the difference between a fire of a plastic bottle and a fire of a engine, not only can you see it, you can also smell it, but that takes some type of experience. If you have never smelled any of them, right? A fire is a fire too. All right, you go up. Now that fire has started. What do? Electrical fire checklist, right? So what do you do?
turn everything off. You read the C's, right? Airspeed, thanks to land, you go through your checklist.
All right, we have turned everything off. We have ABCDs. All right, what would you do?
fly the plane, get to 72.
Right.
And then problem solved. Go through the checklist, make sure that gas is fuel.
All right, what does the checklist say without looking at it?
The engine control unit
Would you touch the engine?
I'm sorry, there, lane A and B.
That's the engine. So you just turn off your well-functioning engine. So on top of that now, not only do you have electrical fire, now you don't have an engine. What would you do, March?
Do that, start, is it, the fire's out, sorry, I wouldn't think,
The fire is not out.
fire's not.
No, where's our panel? Oh, it's right there. Oh, what would you do? Wait, you're private, right?
Yeah.
You're private? What would you do?
I just turn off all the electric master light. Autopilot switch.
So you turn off, let's say all of it on. You turn off the sir?
Turn everything off, the engine doesn't need to run. Stay
Oh, everything, tell me stop, this off?
off, on, on, on. Off,
This one off? Okay,
off, off. Steady.
yeah,
Off,
next one,
off,
ease back up,
everything done.
correct answer, right there. Anything electrical you turn off. So usually you keep this one, you try to keep master with this. The master just controls all of these, right? It's the main bus right here. So if you start turning these ones off and you see that electrical fire is turning off. It's the same method, right? You use it kind of like the method of distillation. You turn this one off and it's still smoky, smoky, smoky. And now it's kind of like smoke goes away. Maybe it was electrical fire was. You turn this one off and you say, okay, this is solving the problem. And I don't have to turn my avionics off. What happens if you turn your avionics off? Yeah, I can't talk to anyone, right? Then I really have an emergency now. Then I can't even talk to anyone. Not saying that this is a priority, but. So what does the checklist say? POH. Anybody got a POH in front of them? Electrical fire.
Master off.
Good.
Ignition lanes.
So what happens with the master off is just the main boss is off, right? You don't know anything, you turn off the master. It's like your how can I explain this? Your master is like extension. You have an extension with like 10 outlets in it. You pull the master, it's like 10 outlets you're pouring at once. Okay. So master off, what's next?
Ignition lanes on, remain on.
It's gonna stay on. If you turn this one off, the engine is gone. You have a bigger problem. Okay, what's next?
Electrical switches off.
Electrical. Okay. Anything else?
Extinguisher use if possible.
Yeah. That should solve the problem, I think, hopefully. Yeah. All right, unless it's like getting worse, right? Electrical fire can also lead to real fire. And that's why you try to avoid it. All right,
So how would you squat emergency code if you had everything off?
I mean, it's not that serious. I mean, at that point, I mean, it's serious, but fly the plane first. Right? Main thing is to fly the plane. If you turn everything off, yeah, you cannot stop anything because this turns off, and this turns off. Now you don't have a transponder, but the priority is really to be safe or not to get any worse. All right, sweet. We go back to the scenario of let's do left turning tendencies. Who wants to explain left turning tendencies? Feel free to volunteer.
Two,
All right, sweet.
four, Newton's third law. For every action, there's equal or opposite reaction. So as the propeller is torquing, it's creating yaw. And yaw to the left.
How does that happen?
As the propeller bites on the down cycle, it bites more air.
That is
That's
feedback.
Um,
You start off with Newton again.
okay,
Let's see if we can solve this problem.
creates the torque.
He creates torque. So there has to be an opposite equal reaction.
Yeah.
What's the opposite and equal reactions turning right? It's turning left. Right? So now you're on the ground. How come the plane wants to turn to the left on the ground?
Dude, color. You're talking?
Mhm.
Because it's just, I guess I pictured of like drag cars, how they twist, it's putting more weight on that left side tire.
Yeah.
Which creates more resistance, which will just automatically naturally pull for the two.
Beautiful. That's definitely the right answer. That's the p-hack answer. P-hack, what axis is this one? This is longitudinal axis. This plane is on the ground. Your propeller's turning. It's turning most likely to the right, correct? So what happens on the longitudinal axis? What kind of move?
We have any
Yeah, what movement? What is this movement called?
spiraling.
A roll, right? Longitudinal axis is in control of the roll of the plane. So this plane wants to roll to the correct and roll on to the right on the ground.
No.
The opposite equal reaction is a yaw to the left because of that.
Because of the resistance of it.
It wants to roll. Plane wants to roll because of that. Propeller swinging it. It's a lot. It's a big force, right? Even though it's only 100 horsepower, but the propeller is swinging that way. So what wants to happen is this plane wants to roll into that direction. Correct? Can it roll on the ground? Hopefully not. So what happens is back left tire feels a lot of pressure now. All right, that was one. You said you're gonna do two. So, you agree?
The other one is spiraling slipstream.
All right.
Corkscrew effect. So as the propeller spins, it creates airflow around the fuselage, hitting the left vertical stabilizer.
Okay.
Tail, causing the aircraft to yaw to the left.
Right. You're creating a so-called downlaunch around the fuselage and it's twisting and the circle is getting bigger and bigger. Okay? The circle is getting bigger and bigger, but you still have a vertical stabilizer attached to the what is this part of the plane called?
The empennage.
Yeah. So this is vertical, this is horizontal. The downwash of that propeller is gonna hit the vertical stabilizer. It's gonna hit it right here. Right, so if I attach anything to this plane now, and I push this, what would happen is plane will be off to the spiraling slipstream. Does a PHAC call it?
The PHAC calls it corkscrew effect.
Yeah. Two more, and I got 4 people.
I don't know what they're called, but I can explain them.
Okay, you explain it and somebody's gonna tell me what it's called.
Gyroscopic recession.
That's the tail wheel.
Huh?
That's really only. Happens, but its tendency is on a tail wheel, because when you lift the back of this rotating motion is here, and when it rotates forward, it turns to the left. It's gonna be like gyroscopic, I don't know how to like the little scientific.
That's gyroscopic protection, right? By lifting the tail, the force will be felt at the tip of the propeller 90 degrees to that point where it has been impacted, causing the plane to yaw. Tip of the propeller, 90 degrees of it causing a yaw movement. Tip, 90 degrees, yaw movement. All right, obviously, if this propeller was turned the other way around, lift it, now where it is here, force is felt 90 degrees to the right. Last one. You did one, you're good to go. So 3 left.
Oh, there's a steeper angle attack.
Oh, you actually want to do it? All right.
Somebody said that one where
He started saying
Okay.
that, he started saying. it.
that's more on the climb. Right?
That's on your
angle.
Because your blade angle is more greater on its downstroke than its upstroke because of the angle that your climbs. It gets kind of pulled off the right. Yeah. To the left.
The angle of attack of the propeller differs as well. To change the angle of attack of the plane, the angle of attack of the propeller will change. Now in pilot terms, now the descending blade is getting a greater bite of the air, pushing the plane to the south. Okay?
What's that called?
There's a descending blade and there's an ascending blade.
No, what's that?
Effective peak effect.
P for propeller.
P for propeller. Everything is associated. P, I don't know, you guys know Factor? Maybe, anybody know Factor? The subscription meal company in LA? It's like a meal prep company in LA. It's called Factor.
Yo.
So one bite eating more than the other side. I just memorized it.
Oh.
All right. Next one up. 3 types, or let's talk about stability. And we're gonna keep it basic. We don't have to go commercial. What is dynamic stability? You, and you. I got 3 more. Dynamic stability. Over time, starting off right. The dynamic, it's maybe helpful to understand what dynamic means. Dynamic means nothing else but over time. The tendency of the plane to return to its original states over time. How many types of dynamic stability? There's positive, negative. Yes, positive, negative, neutral. What is positive dynamic stability?
Positive means over time, we just get back pretty spending from. Like negative, it just keeps going worse. Like over time, it's just gonna get worse.
Okay.
Positive, it's just over time it'll fix itself. And neutral is it won't fix itself until you put it in.
Yeah. Positive is this plane, it's gonna be hit by an updraft or a turbulence or whatever. And it's gonna go up, down, up, down, up, and down. Comes right back to where it started. Negative, this plane, it's gonna be hit by something, now it's facing up. Go up, down, let's go further up, further down, further up, further down, further up. It's never gonna get better, it's getting worse. Neutral, up, down, up, down, up. Staying in that state of oscillation.
So porpoising when you're like landing and ground effects, is that control or it depends how much, how bad it gets?
And hopefully you do something about it. As in like a balloon or something, you mean, or as in
So when
like,
you're landing and you start porpoising, right?
yeah,
Back and then.
yes, it's way you can fix it, right?
Yeah, yeah. It's that,
Fix it. You ask or you can fix it, you just, if it's ballooning, you just hold it, you don't try to climb up to it or descend to it.
I
Just
guess,
level it up.
does that fall under
Stability,
stability?
sure, there's some type of stability, but you will kind of have a greater.
But it's not like self-inflicted though, so it's-
Yeah, yeah, sometimes it can be self-inflicted too. Stability doesn't mean it's only by outside. You have a greater input in regards of how to fix that problem. But turbulent air, there's little you can do. I mean, obviously you can try to put the plane in maneuvering speed and this and that for it not to fall off the sky, but if you get hit by something, you want to see if the plane will return to its original state. You can practice it outside in the practice area. Let's yank the stick one time and then see what the plane is going to do. Does it come back to its altitude if you were trimmed correctly? If you yank it, does it go up and down, up, and then it will eventually come back to, if you don't touch the power setting, if you don't touch the trim, it should go back to where you were. Because it's a stable plane. All right, static, I give it away. It's a screenshot in time at that given moment. Where does the plane or where's it gonna end up? Positive, not neutral, or negative? Is it gonna get worse? Is it gonna get back to its original state? Or is it going to neutralize right there where it was? If I hit it, if I hit this plane, is it gonna stay neutral just in this climb? If I hit it, does it get negative, as in like, it's gonna get worse? Or if I hit it, it's not neutral and it's gonna stay in this new state. Okay? Any question? No question, huh? I have a whole lot of questions. How do you explain lift? Explanation of lift. Basic. It's what my nephew asked me. How does a plane fly? Pretend like I'm the nephew. What's that?
It just does.
It just does, yeah. It just does. It's magic. To some degree it is. Because these are all just theories, you know. Anyway,
Alright, I just see this, you got the relative wind, and then the chord line creating your angle of attack. And then pretty much Bernoulli's principle is the wind over your beat. As a over. And the wind under with higher pressure pretty much created such.
good, very good. With a little bit of confidence, you could have answered it just fine.
I just forgot if it was low or top, I remember how.
Why is it low pressure on top?
Has a greater surface to cover and it's pretty much liquid. It just speeds up.
Air is a liquid. The top part of the wing has a longer surface. So therefore, the air that is being separated at the leading edge is trying to gain back. They want to come back as a community. You can think of it as a community. The leading edge is going to separate this community that loves to be together. And this top part of this wing has a longer surface. So therefore, these people out here, or this air liquid, or air molecule, is trying to speed up to get back to the high pressure, or the air that's going from underneath. The air underneath doesn't really have to travel that fast. They have to travel faster because it's the distance. So this is creating low pressure. The air that is traveling faster is creating low pressure. The air is traveling underneath is creating high pressure with a constant speed. Then they gather here again, and what happens, they create some type of suction. And this suction is going through. All right, that's one. Second one.
Question is what rates lift?
Raise it.
Top of that, it's your angle of attack, right?
Yeah, I mean, there's a theory, there's one more theory.
Lift is your lift is, well, it's greater than your weight.
Yeah, I mean, yeah, sure. You can also talk about forces of flight, but it's literally just they just ask usually about the theory of, which is Bernoulli's principle, always against. Bernoulli was a Swiss mathematician, if you really want to go into detail, but and then there's Newton. Somebody always has to think they're better than. So there's Newton, and he thinks he's better. And he says, my theory is that the relative wind is hitting the bottom part of the wing. There's an opposite and equal reaction. And the opposite and equal reaction to this is the wind hits it here, plane is gonna lift it, creating a force. Anything you push this table, either the table's gonna move or I'm gonna move, right? With enough force. So I'm pushing hard enough, it's probably me because I have the tires and my chip. So that's the force, right? It's the same with the wing, but this is a wing. I go like this, and now the wind is hitting it from the bottom here. There's a force. It's either the table gonna move or it's probably not gonna be the room. The tail is probably gonna move, right? So it's gonna be lifted upwards. That's your lift. In Newton's theory. In a nutshell. All right. What about 5 minute break? We come back, we finish off with 30 minutes, and then we're done for today. All right.
At some point we'll be firing up all these answers.
All right.
That's still a good one.
Yes, you can. Yep. Yep.
Place the aircraft. What did you learn?
Here.
Oh, here?
I thought it was zero.
Oh, wow, okay. You're all clean.
All staying out. Yeah, that's where I learned.
Says not, did you ever phone us?
3 times.
Okay.
Yeah. I wouldn't say I'm proficient, but yeah, did it 3 times.
All right.
3 only. It's not that difficult really. Feels more stable.
Yeah.
Happier. So. It's good. What about you? Where did you go from?
About 30 years ago, I wanted to.
Oh, wow, I wanted mine. Yeah, right on.
Yeah, right on. Yeah, we went, a couple days ago. Yeah, first time I landed there. Yeah. 30.
Wow. Beautiful experience. All right. So let's see what else we can do. Anybody wanna, even though this is, the chance of this being asked is very little. But
Check right or on the exam?
on a check ride and a paycheck, but
Okay.
to a certain extent, it's kind of like a potential question. How does a fuel injection work in the ULS or in a non-IS, I should say?
Covered.
That's a carburetor, yeah, that's correct. So how does the system know how much fuel to inject, which is already happening kind of automatically, right? Except of the mixture, right? How does the fuel go into the system?
Got tanks.
Yeah, that's good.
There's a float. Got tanks, you got them coming in.
Okay, let's take it back. Explain to me the fuel system for an IS.
Electronic fuel injected.
Fuel system in an IS, correct?
2 fuel pumps.
Let me see. We probably have done the drawing, but by the time I find it, I'll just do it over. So we have the IS system. Which one? This one. Here we go. Fuel. Fuel system, fuel consumption, you know, that part. It's kind of like towards the end of this. Oh, look at that. Electric system, fuel system. So in the IS system, you have this one wing, two wings, fuel selector, either left, right, or off. This is the first filter, correct? This is your strainer. Then it's going to run into what? What's the next step?
Escalator.
That is correct. So if you look at this, for example, you have one fuel tank, the second fuel tank. This is marked as A right here and B right there. So A is there, B is there. What's the next thing? You have your fuel selector, correct? Which is here now marked as Juliet, J. Fuel selector right there. Where does it go next? It will go, we will kind of like skip these T's, okay? It will go to the so-called I. So what is I? Is the feed pump, okay? It's just like pulling it pretty much, but then it will go to your F. What is F? I just heard it earlier from someone. Yeah, so this is your gascolator. Here they call it the so-called and air gascolator, but gascolator will do the job. The lowest point of your fuel system. This is where you can also get a fuel sample, right? So you can get a fuel sample at the wings. You can get a fuel sample at the gascolator. All right, after the gascolator, where does it go? That is absolutely correct. How many fuel pumps do we have?
2.
So there is your Rotex 1 and 2 fuel pumps. Where does it go after that? Fuel filter, yeah, correct. So now you're walking it through here and it goes to the final filter. And what is this little?
It's a pressure bypass, so if the filter gets clogged, you will still get fuel pressure.
Absolutely.
It just bypasses at a certain PSI. Yes.
Yeah, so this is the so-called bypass. If this is clogged, for whatever reason, it will just walk its way around it and still provide fuel to the system. Last thing is going to be, or second to last, I should say. What is the last one? Or second to last? Here. And this is the Rotex engine. What's the last thing? Fuel, pressure, sensor. Everybody see this part right here? It's marked as G. G as in golf. Fuel pressure sensor, you see it? And then finally, it's in your engine. How much fuel runs through your line?
20 gallons per hour.
And why is that?
I don't even remember.
Well, it circulates, it also uses it to cool, right?
Yeah. It runs more fuel through the system because fuel is also a type of cooling. And where does the fuel go back after it has not used those 20 gallons?
To the tank, that is so.
That's it. All right, so beautiful. Just like that. Left, right, strainer, selector, gascolator, pumps, bypass, and the last filter, fuel pressure sensor, how much is going, it's sensing how much is going into the Rotex. The Rotex takes it, whatever is not burned goes back into the system.
So it goes back into your selected fuel, so over time, that fuel tank will increase its fuel quantity?
No, if you select the same, it's the same amount. Because it only draws from one
It's only burning like 5.
and it goes back to the same
it's
one.
Going back to the same.
Same one.
Yeah.
Yep. Yep. So, all right, somebody explain this to me. Somebody explain this to me.
Generator AB.
Maybe.
Then from there, it gets transferred from AC to DC current.
So this is AC, which stands for nothing else but alternate current. Okay. And now what is this?
Fire regulator, you call
Rectifier regulator 1 or A, you can call it. Rectifier regulator B. And what happens here now?
DC. Direct current.
So this is now DC. And how does DC look like? Hopefully like this, right? All right. So this is direct current. This is AC current. This is DC current. Where does this go?
Into the ECU.
What does the ECU control?
A, E, which.
Injectors, spark plug, and fuel pumps. How many injectors?
8,
Spark plugs,
8,
pumps. What goes into here?
to main battery,
How big?
12.
What does this control? Good. Good. What is this part right here that I drew? And what is this part?
That would be your crank, your prop.
Crankshaft? Okay. And what is this part?
Your gear reduction.
Mm-mm. What's attached to the?
Magnet.
That is it. That is the magnet, correct? And the magnet starts rotating, right? And the stators are fixed. The magnet is what rotates around it. Yeah.
Yeah.
So this one has how many stators? 24 stators, correct. Like this, right? How much RPM do you need to start the second generator at startup?
No.
How many RPMs do you need for you to be 25? Mhm. What if you don't start the second generator? Yeah. This is called in physics, I don't know, probably later in commercial you will get there, but this is called thermal energy. Create thermal energy. If you have too much thermal energy, heat, it can melt your generator. That's why you start your second one. You start that second one, it knows how to distribute the heat from alternate current to DC current. So forth. What happens if generator A fails?
You lose half of your like.
Generator A fails, what happens?
This is the fuse box know to transfer from red part E to A.
Yeah, it will always prioritize your engine.
That's done in the lanes electronic, right?
Yeah.
Lanes will decide.
I mean, technically, it's the fuse box. It doesn't get too much credit, but the fuse box recognizes that the engine control unit now draws its energy from the generator that is still functioning. All right, final question, and then we're done for today. Should we? I mean, there's so many questions I can really ask, but. All right, we're finished with this. How does a stall happen?
See the critical angle of attack.
You exceed the critical angle of attack. What is the critical angle of attack?
To when the board line.
So now I go here. This is your wing, right? What is this part called?
The leading edge,
Leading edge. What is this part called?
trailing edge,
Trailing edge. Where is that chord line?
imaginary line through the center.
A straight line, pretty much. Don't judge my drawing. So this is called the what?
Portland.
Chord line. So the relative wind is coming like this. Where is this so-called angle of attack?
Stand between that port line and the relative wind.
Yeah.
Ah, shit. So the angle between here and here is called your angle of attack. So say that statement again. Craig, please.
Stall happens,
Uh-huh.
exceed critical attack.
Good. This is an angle, right? If you exceed this critical angle of attack, let's say this is the so-called critical angle. Oops, sorry. This is the limit. Anything above it will be called the critical angle of attack. Anything here. You see how you increase, let's say this is an angle of 11 degrees, right? This one at the limit here is 15 degrees. If you exceed 15 degrees, you're getting into the so-called critical angle of attack, let's say 25. These are just rough numbers, okay? This is not like one-to-one. You exceed your critical angle of attack, and what happens?
That is
Your airflow gets disrupted, so you're not creating. Loads.
Good. Where does it start? What's outside? Wingtip?
Yeah. No,
No,
The body.
Yeah,
Yeah,
it's
sorry.
it's at the root.
Yeah.
And where does it, how does it move? Okay, what is center of lift? What?
center of lift.
Yeah. How can you substitute that word? Well, what can you substitute the word and it's still the same?
And gravity, right?
Mm-mm. Center of lift is equal to center of. They carry the same. Center of lift equals to is the same as center of what? Center of pressure, maybe?
Your weight.
No, center of, I just said it.
No, I know.
Center of
I thought
lift,
you were trying to look for something.
center of lift is equal to, as you're increasing the, this is your center of lift, right? Right here, at low angles of attack. If you're increasing the angle of attack, where does this move? Backwards or forward? It moves forward. Center of pressure or center of lift moves forward with an increase of center of, or center of lift moves forward with an increase in angle of attack. So if you're moving forward now with a center of pressure, because you're moving or you're pitching up, your center of pressure is moving forward, correct? So now if I look at the surface of this wing from above, let's say this is the wing, right? Now I look at it from this perspective, right? This is my fuselage. So this is the airplane. This is how much surface you have to create lift, correct? If you're now increasing your angle of attack, what's going to happen? The center of pressure or center of lift or center of pressure, same thing, is going to move, for example, from here to where?
Forward.
To here, right? And it keeps moving forward at any given point, really. It keeps moving forward, right? So at first, with no angle of attack or slight angle of attack, you have the entire surface that is able to create what? Lift. If you're moving up in a sense of you're increasing your angle of attack, now guess what? It's It's only the green area that is producing lift, correct?
Mhm.
So what happened to this part?
Disturbed air.
Yeah, disturbed air that is not creating lift. So if you create even more, a greater angle of attack, now you're using only this part of the surface, correct? And what area is not being used? So guess what? Are you going to create enough lift if you have a too high of an angle of attack on this little bit of surface? That's the answer. Center of pressure equals center of lift. Center of lift moves forward with an increase in surface decreases within what? Angle of attack. Surface available, surface usable, whatever you want to call it, right? Let's finish off with this and then we're done. So if you're looking at this now, where should it start curling up, or where should these chord lines?
At the back.
Which one's still producing lift? And this one almost stays until the very end. If you really look, there's another, you see this one? Pay attention to all of them except of this one. So we said it starts at the root, right? This is the last one that really loses. It starts at the root and then it goes outward, right? So once again, you're looking here. You see the other ones over there?
Mhm.
Are they still creating lift?
Yeah.
Is this one creating lift?
No.
Is this creating lift? No. Is that creating lift? That's what, that's why they say it starts at the roots. Yep. All right, guys. Thank you. I'll see you next time.
Thanks.
Yeah, you got it.
Thank you.
Have a good one. Take care. Daryl's here. Sure.
Yeah. We can't go. Thank you. Appreciate it. Yeah.
For Monday, we're gonna review again.
Monday starts review for the entire year.
So we just do review for 2 weeks, right? When one of those last one.
Really?
I take that.
You get a study for that.
Kevin's